Okay, so start out saying, you'll notice I got a little question on the board. I want you to put those three things in order from least to greatest. I got A, the number of stars in the universe. B, the number of seconds since the Big Bang / when scientists consider the beginning of time. And C, the number of possible configurations of a deck of 52 cards. So when I say configurations, I talk about the possible, like, the orders that I can put them in. So, if I had, like, this deck of cards here, a different configuration would be even just moving one card. Or shuffling the whole thing. That would be a new configuration. So talk about it with your partner. Put it in order from least to greatest. You're like, don't worry, I'm not going to be like, oh, you didn't get it right. But just think about it. Go for it. Least to greatest. So the smallest to the largest.
I agree with you.
Dude, I hope you know. I hope you know. So you think C is definitely not the smallest.
What do you guys think?
I thought it was
We don't know the number of
CBD.
stars in the universe.
Well, you don't know any of that. Right? No. If you did, it would be easy. So what do you think? It's just your prediction. What do you think is the smallest?
Wait, do you know the answer?
I do know the answer.
Well, so do I.
That's kind of what?
Because the universe is constantly.
Well, I came up with the question, so I probably do know the answer.
So that means that the.
Okay, this group right here in the middle. What did you say was the smallest?
C A.
Okay. You're good. You're good. C. Okay. Who else said C? Who else thought C was the smallest? Okay, cool. So we thought the number of possible configurations of the deck of these two cards was the smallest. Anybody say something else? What do you think was the smallest?
B.
What do you think? You think it's A. You think A is the smallest, okay?
We thought B.
B. Alright, so we got a little of everything. But like in general, the most people thought C was the smallest. Okay, how about the largest? Which one's the largest? B, okay. B, I'm hearing a lot of A. Okay, let's talk about it a little bit. Who's good at shuffling for me?
Me.
You're good? I'm terrible at shuffling. So, you shuffle this deck of cards for me.
Three's
Is it
favorite.
because I'm a super senior?
It's because he was quicker than you.
It's because he's better.
Okay, the number of stars in the universe. The number of stars in the universe, scientists estimate, is about 10 to the 23rd. Okay, that means a 1 with 23 zeros behind it. That's about how many stars are in the universe. Okay, the number of seconds since the Big Bang. Anybody want to give a guess?
10 to the 21st.
10 to the 13.
10 to the 13th? Okay, that's pretty close. I mean, kind of. How many in years? How much do you think it is?
10 million.
10 million, that's pretty close.
14
I
million.
thought it's like 130 million.
14 billion, that's even closer. Okay, the estimate is about 13.8 billion years since the Big Bang. So that's 10 to the 18. So that's 1 with 18 zeros behind it. Seconds. Seconds. 10 with 18 zeros behind it. 10 seconds. We could figure it out. How would you figure that out? If I told you the universe
I
is
thought that was
13.
years.
This is seconds.
Well, you're wrong.
Seconds. It's 13.8 billion years.
Just gotta multiply 10 by itself, 18.
You're so super.
Good. How would I figure out if I gave you 13.8 billion years? You tell me this is baloney. No way is this true. How could I figure that out?
Google.
Google. How could you figure that out with math? You probably know how to do it.
Take that number. 300.
Somebody say anything? Any ideas?
I'm gonna get one shuffle.
Conversion.
I'm
Good.
trying, but, hey, there's a joker. in
Okay,
there.
I heard you say something. You got 365 what?
Days.
Good. There are 365 days in a year. So I can multiply this by 365 days.
Wow.
How many hours are in a day?
24.
Times 24. What would be the next number I multiply by?
3600.
60. Okay, then I've got it to minutes, and then I multiply by what?
16.
60. Okay? That's how you would figure out if this is baloney or not.
Okay, what is it?
Okay, any guesses for how many ways you can shuffle? Just shuffle it one time. You can take the joker.
246,000. 831.
256,831.
How'd you go with that, right?
I don't know.
I like it. I like just throwing out a guess.
No, it's
Okay,
a
that
little
is
higher than
way too low.
Wait,
It's a little higher.
Way too low.
1.5
You have to do 52
million.
times 52.
1.5 million. Way too low.
2.895.
Too low.
Way too low.
3 million.
Way too
52 to the exclamation point.
1.2 billion.
Nah. 24.
What'd you just say?
52 to the exclamation point.
52 the exclamation point.
What's that called? Factorial?
He's right about that. We're gonna talk about that later. 52 to the exclamation point. Do you know what that
Man,
means?
you should be at the match.
No. 52.
What the heck?
52.
52. This is called 52 factorial. Okay, what this means is, this means if you see this math, it means 52 times 51 times 50 times dot 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 all the way to 3 times 2 times
Yeah,
1.
how'd you know that?
Because I'm built different, obviously.
Okay, how did you know that?
I don't know.
Because he's
I'm like that.
He's a big match.
You didn't just guess. How did you just guess? How did you know it was 52?
Oh, well, because there's 52 cards.
Good, there are 52 cards. So, how many possible cards can be in that first position? 52. Okay, I just used one. How many can be in that second position? 51. How many can be in that third? 50. Okay, I keep going until I get 3 times 2 times 1.
Do it.
Hey, if you do that with calculator, are you doing it? Do you know how to do that on your calculator?
I don't think I was trying to do the billion.
Okay, you get something that is like 10 to the 68.
We hit the order.
Oh,
so
so
I was right.
To the 68. So which one's the biggest?
Shit, what's the name, huh?
BAC?
Yeah,
Which one's the biggest?
C.
C. The number of possible configuration of the deck of cards is
I like
bigger
that.
than all those. Okay, let's talk about what that means a little bit. Reese just shuffled my cards for me,
Like 8 times.
like 8 times. How many times did it take you to shuffle it like once? Or like how long did that take you? Sorry.
Like 5 seconds.
It took him like 5 seconds. Okay, it took him 5 seconds to shuffle it one time. Okay, what does this mean? What does this 10 to the 68th mean? Okay, 10 to the 68th is bigger than how many seconds there have been since the Big Bang.
Wow.
Okay, so let's think about that. If he shuffled, if Reese started shuffling since the Big Bang, every single second, if he shuffled every single second, he still would not have hit every single configuration of cards.
Wow.
Isn't that crazy? So, if you shuffle a deck of cards, it's pretty likely that that is the first time a deck of cards anywhere has been in that order. I know, it feels impossible.
Me and Reese David.
Man, you're special. Yeah, I did that, guys. It hurts.
But it's true.
Yeah,
Okay,
it gives me an
the
all-
reason I wanted us to talk about this is deck of cards are going to come up a ton in stats. Like we talk about them all the time. So what's in a deck of cards? Some of you might not know what's in a deck of cards. Hey, I've got a card right here. What's special about this card? There are 2 things that are special about this card.
Hearts and queen.
That's a face.
Hearts and queen. So when I have a deck of cards, okay, each card has a suit. What are my 4 suits? Hearts,
Clubs.
hearts, diamonds, clubs, and spades. Okay? Hearts and diamonds are what color? Red. Clubs and spades are what color? Black. Okay? And then each one of them has like a number or a letter. What are the numbers and letters? Possible numbers and letters. Good. I got ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then jack, queen, king. So how many cards are in a suit? 1 suit. So how many diamonds are there?
13. Darn.
13. It goes ace through 10, so that's 10, plus jack, queen, king, so there are 13 in each suit. Then there are 4 suits, so how many cards total are there?
Probably like 50.
52.
And there's 2 tokens.
Okay, perfect. So
Now you mess it.
there are sometimes 2 jokers. Okay, I want somebody to pick a card for me. Who wants to pick a card?
I don't.
Is this a magic trick?
I'll pick a card. What's your name?
That's super kid.
Eli. Okay, Eli's gonna pick a card. And then anybody else want to pick a card?
Probability
You guys?
and statistics to determine.
Don't worry, this is not a magic
Eli,
trick.
don't show anyone.
Do you have any magic tricks?
I don't have any magic tricks, but maybe I should learn something before I do all this stat stuff. Okay, yes. Eli, tell me what card you got. It's not a magic trick. Tell me what card you got. A king? Okay, what was your suit? Diamond. So he got the king of diamonds.
Shut up, Jaden.
Okay, I'm sorry, what's your name? Olivia. Olivia, what card did you draw? The 5 of clubs. Okay, the five of clubs. I'll take your cards back. Alright, I'm shuffling these up again. Okay, I need two different people who can draw the cards that think they can get a king of diamonds and a five of clubs. Again.
That's impossible.
Think you can get it again?
King of diamonds.
Oh, really, watch out.
Both. I want him to get the king of diamonds and then I want you to get the five of
Oh,
clubs.
that's a bit
What if they do the other way around?
Okay, if this happens.
I'll give it to you. This is not a magic trick.
Are you sure?
It definitely is magic.
It's only a 1 in 2,500 chance.
Oh, not you. Adrian.
Ah.
Ah.
You know what I'm saying?
Okay, what's your name? Marcos, what did you get? The 10 of diamonds. Oh, he was kind of close. The 10 of diamonds. What did you get?
Adrian.
The 7 of hearts. Okay, they got the 10 of diamonds and the 7 of hearts. What was the probability? How likely was it that they were going to get the right card?
1 in
2 out of
2,500.
52.
Okay, I kind of like your thinking.
2 out of 10, 60.
How did you get that?
So just say 50 times 50.
Okay, Marcos drew the first card, right? And he was trying to get the king of diamonds. Okay, I'm trying to get, I want to know the probability of getting the king of diamonds on the first draw and getting the 5 of clubs. I want to know that. It's not impossible. It could happen, right? They could draw, right? Okay, what was the probability of getting the king of diamonds?
1 in 52.
1 out of 52, good. There's only one chance out of 52 cards. Okay, I have the word and. You're going to find out in stats, and a lot of times means multiply. Okay, so what was the probability of getting the 5 of clubs? Given that, okay, for him, given that that one card was already taken. 1 out of 51. Good. So let's talk about what if Marcos had chosen the right one? Okay, let's say that was lucky. What if he had chosen the right one? Okay, what was the probability that Adrian would choose the correct one? Good. Still, it would still be 1 out of 51. Okay, so would you agree this probability right here is the same as the probability of getting the king of diamonds times the probability of getting the 5 of clubs given that he just got the king of diamonds. Okay, the probability of getting a king of diamonds and the 5 of clubs is the same as getting the king of diamonds times getting the king or the 5 of clubs given that he just got the king of diamonds. Okay, that's just something to think about. So what did we just learn there? I just learned the multiplication rule.
Oh, it's yellow.
The multiplication rule says the probability, you're going to want to write this down. It's in yellow, remember. It's in yellow, we're going to want to write it down. Thank you, my cards
I
down.
like that.
Thank you.
You missed all of this yesterday.
Thanks for volunteering.
Yeah, I was thinking of PSAT. I was busy eating a brain fried. Actually, it wasn't even that far. I got a headache. What?
Are you excited for Christmas?
It was actually way easier than.
Please get out your notes. Getting out your notes does not require a conversation.
Yeah, so it's not required.
Oh.
That didn't make any sense. Multiplication rule. The probability of A and B, the probability of both events A and B happening is the probability of A times the probability of B given that A just happened.
Like that.
Good question. What does that upside down thing mean? Okay, I'm going to use this a lot. That just means and. Okay, the upside down thing, if I put this in between here, yep, if you see that, that means the probability of A and B. If you have trouble remembering that, and has an N in it.
That doesn't help.
Okay, it has, hold on, and has an N in it. If I erase the A and the D, it looks like an N. I think that looks like an N. Or if you say A and B, it sounds like A and B. That's how I remember it. Or if you refuse to let that make sense to you, then come up with your own way. independent, the probability of A and B just equals the probability of A times the probability of B. Okay, my events were dependent there. They were dependent because when Marcos drew this card, he kept it. Okay, how would I make it independent? If he put it back. Okay, if Marcos put the card back and then I had Adrian draw, what would the probability be that we got both of them right? What would be the probability that Marcos got it right?
1 in 52.
Good, 1 out of 52. What would be the probability that Adrian got it right?
1 in 52.
How many cards are in that deck now? Now that Marcos has replaced it. 52.
So 1 out of 2,000.
Did you figure it out? Did you plug it in? Next.
It's kind of cheating, you know, don't work ahead.
Okay, let's talk about why this makes sense. Why does it make sense that if I go from this formula to this formula, I would change these two things? Okay, what do you remember yesterday about my 3 conditions? My 3 conditions to be independent.
I was in here.
Okay.
I didn't write that down.
I wasn't here either, guys.
Somebody wrote it down, it was in yellow, so somebody wrote it down.
Oh, really?
No, I didn't.
Replace whatever is new.
Okay, I had something that said P of B, and then I said that equals the probability of B given A. So notice here, that first formula, I've got probability of B given A. It equals this when it's independent, so I just substituted this probability of B into here. That's how I got that formula. Okay, let's talk about this. New example. Alright, I want you to find the probability that a randomly selected Sioux Center student goes to either homecoming or prom.
Do I have to write this down?
Goes to either homecoming or prom. 72% of the students go to homecoming. 42% of the students go to prom. You guys have prom here?
Yes.
Okay.
Who goes to homecoming?
Oh, get math done.
Alright, everybody stay with me here.
Shut up, Katie.
Why does it make sense that more students would go to homecoming than go to prom?
Because
Homecoming's more fun, maybe.
all the students can go to homecoming.
Good, all the students can go to homecoming, only some of the students can go to prom. Okay, in stats, this is very important to remember. In stats, Venn diagrams are going to be very helpful to you. Venn diagrams. Anybody remember what a Venn diagram looks like?
2 circles overlap.
You're good. 2 circles overlapping. So, I'm going to draw a Venn diagram.
Just in she's talking about how much you're going to
Okay, I'm going to say one of them represents the students that go to homecoming. Okay, so any student in this circle went to homecoming. And I'm going to say another one represents prom. Any student in this circle went to prom. Okay, what would the overlap mean?
They went to both.
Both. Okay, this is called the intersection of H and P. So this is P, H, and P. Okay, what would just this part represent?
P.
Okay,
P of P.
does this just represent the students who went to prom?
Yes.
This right here. If I take out this middle part. They went to prom.
But not homecoming.
Good, they only went to prom. What does this section represent?
Yeah.
They went to only homecoming, not prom. What does the outside represent?
They didn't go to either.
They didn't go to either one.
Party pooper.
That's me.
Okay, I want to know. Stay with me. I want to know.
Social like.
There's a little too much talking going on. Okay, I want to know. Find the probability that a randomly selected student goes to either homecoming or prom. So I want to know the students that are in either one of these circles. So I want to know the students that are in here, here, or here, but are not out here. Okay, there's a 72% chance of students going to homecoming. So what's the probability that a student goes to homecoming?
72%.
Okay, my probabilities have to be between 0 and 1. So how would I change that?
0.7.
Good, 0.72. So the probability of going to homecoming is 0.72. What's the probability of going to prom?
0.42.
Good, 0.42.
Yes, sir.
Okay, how would I figure out this circle is 0.72 and this circle is 0.42? How would I figure out how much this whole Venn diagram is? Any guesses? Don't be afraid to be wrong.
Oh, wait, 100%. Oh, wait, no.
Okay, what's kind of making you think that it might be more than 100%?
Doesn't add up.
Okay, so you started adding them, right? So you said, okay, 0.72 plus 0.42. Anybody have their calculator? What's 0.72 plus 0.42? Or who can do that in their head?
1.14.
1.14. Good. 1.14. Okay, what's wrong with that? What rings a bell there?
You can't have more than one person be a person.
I can't have a probability greater than 1. I can't be 114% sure.
That's where the mix in the middle comes.
Okay, so what did we do wrong there?
We added them instead of, we used Keaton's method.
You didn't consider if they went to both. So we counted all of these students. And then we counted all of these students. So we double counted this middle section. So I gotta somehow subtract this middle section. I left this out on purpose. I need to know how many students went to both. I got that 27% of students went to both.
What about the people that didn't go?
So how would I figure that out? I do 0.72 plus 0.42 minus
0.27.
0.27.
Oh, yeah.
Me, 0.87.
0.87, everybody agree with that?
13%.
Okay, so that tells me 87%. That tells me 87% went to either homecoming or prom. Okay, somebody just asked a really good question. What about how many students didn't go to either one? How would I figure that out?
13% left over.
The 13% left over. If 87% are in one of these two, 13% are outside. Or 0.13. I need it all to add up to 1. So what did we just learn there? If I say or, I use addition. Okay, and means multiply, log stats. Or means addition. So if I want to find the probability of A or B, the probability of either event A or event B, or both happening, I need to do the probability of A, one of my circles, plus the probability of B, my other circle, and then I want to subtract whatever's in the middle. That probability of A and B.
The or sign will be the opposite, man.
Yeah, good. The or is pointing up.
Additional.
Okay, somebody who was here yesterday. What do I know about mutually exclusive events? They what? They exclude each other. Good.
There's no possibility that
Can't
it
occur
could
at the
happen.
same time.
They can't occur at the same time. So what did I say? The probability of, if A and B are mutually exclusive, the probability of A and B happening was what? Mutually exclusive. They can't happen at the same time. So the probability of both of them happening is what? 0. Okay, so for mutually exclusive events, my probability of A and B is 0. So I just drop that part out of my equation. So if two events are mutually exclusive, I can use this equation.
Actually, you're bringing in.
Okay, we're going to do a worksheet to help you work on these things. Okay, we've gone through 3 sections in this chapter so far. After this slide, once everybody gets it down, I'm going to put a possible equations that you might want to use on this worksheet up on the board. The right side up there is that means or. So down means and. We use it. Good question.
Is this homework?
This is homework.
Why?
I think you're going to find that they're faster than you think. Here's our wording.
Yeah.
Okay, everybody look at their sheet real quick. I had a little printer error. Okay, you look, it says number 2. It looks like there's nothing there. Okay, on my computer it looked fine, but on the printer it went down below. So number 2 is where it says probability of A equals 1/6. Probability of B equals 3/5. And then probability of A and B equals 1/12.
Oh, we did that for all of them.
Whoa.
4, 6, 8.
Yep, sorry.
That's okay. That's just like when we do this in Vegas, sometimes country, you open on your phone.
Alright, you want to start the first one together?
Yeah.
Here are the possible equations that you can use.
So where's that right
Okay, that first one, it says, determine if events A and B are independent or dependent. Okay, if they're independent, I know these three things are true. If they are dependent, I know these three things are true, that they're not equal. So, right here, I've got P of A equals 1/7. Probability of B equals 3/7, and the probability of A intersect B, or A and B happening, is 3 out of 49. Okay, which equation does that look like up there? To prove that, I'm gonna see, are they independent?
That looks like.
It looks like,
The additional.
The bottom.
it looks like the bottom. So if I say, if I want to prove they're independent, I gotta prove that the probability of A and B equals the probability of A times the probability of B. Okay, I'm gonna put a question mark here because I don't know if that's true or not. I don't know for sure if that's true. Okay, what's the probability of A and B? It's right on the sheet.
1/7 and 3/7.
No, probability of A and B. Probability of A intersect B.
49.
3 out of 49, good. Okay, what's the probability of A?
1/7.
Good, 1/7. What's the probability of B?
3/7.
3/7.
Yes, sir.
Okay? What's 1/7 times 3/7?
3/49.
Good, how did you do that?
1 times 3, 7 times.
Good, when I multiply fraction, I multiply the top, that's 3. 3 times 1, 3. 7 times 7, I multiply the bottom, 49. So, they do equal each other, so what do I know? They're independent, so all you gotta write there is they're independent. You also need to write something that looks like this. Some sort of work, so that I know you're not just guessing.
Yes.
Because if you guess, what's the probability that you're gonna get it right?
Probably like
50%. 50%, good.
Well, but if I get them all right, then after that.
Wait, so,
Must be doing some.
so if they equal each other, they're independent, but if they don't, then
Good. Good, we talked about that yesterday. Okay, the people who were not here yesterday, you are gonna, how many people was that?
like me, and then me.
6 people? 5 people?
What's your right now? Yeah. Which is all of them.
Okay, Mr. Cundy, would you recommend that I move them up to the front and show it, or just work them at their?
Let's do this.